I know a bunch of you are not able to play the simulation, so I'm going to go ahead and demonstrate that. I'm going to go ahead and run this Java program. Hopefully it will come up in just a moment. And basically I will demonstrate what needs to be done as far as collecting data goes. And then from there you can go over to the template to complete that. So we're going to start with the part 1, which is constant velocity. And here what we want to do is choose a constant velocity. So I'm just going to choose 2 meters per second. And then we will play a little simulation to see what the graphs turn out to be. And I'll stop him right there before he hits the wall. So you can see we have some data here, a time of motion, his position, velocity, and acceleration. You can record the graphs for question number 1. And then question number 2 asks you to take some data from these graphs and come up with a story problem. Design that story problem so that it includes both velocity and distance. And then move on to question 3, where you'll actually do some calculation. Ideally, when you get to 3B, your calculation should agree with what you see here in the simulation. If those numbers don't match, that may be an indication that you need to go back and make some corrections. All right, so that was part 1. And like I said earlier, if you need to pause this to mark down your graphs on the template, you can go ahead and do that. When you are ready, go ahead and press play again, and we'll move on to part 2.
Hi everyone, this is a new recording for part 2 of the 208 lab. What we're looking at is constant acceleration. So I know some of you can't run the simulation and you can use this video to collect the data that you need. Question 1 says to record the initial velocity and acceleration. So I'm going to set the initial velocity to 1 and we're going to set the acceleration to 2.5, so 2.5. So those are set right there, and those can be recorded in your file. The simulation will generate the graphs for each. So I'm going to go ahead and click play, and what I'm hoping to do is stop him somewhere here by right after his house. So we'll see how that goes. All right, there we go. So what we have are some pieces of data that are helpful to us. One would be the position time graph for acceleration. You'll want to record this in your file or take a screenshot. And we also want to make note of the endpoints. So this graph is starting at 0, 0, and it's ending at 2.5, comma 10, roughly. I want just a smidge past 10. The next graph is a velocity time graph. It starts at 0, 1 due to the fact that his initial velocity was 1, and it continues in a straight slope to the end here at 2.5, comma 7.146. So that would be the ending point there. And lastly, the acceleration graph, and we can zoom in on that. If I click the zoom in button here, it might be a little bit easier to see. We are just a smidge above the 2.3, and we know technically it would be 2.5, 2.5, because of the fact that that's what our constant acceleration was set at. And that's saying the same the whole time. So therefore we have a horizontal segment here. Starts at 0, 2.5, and it ends at, I guess, 2.5, 2.5, due to the fact that the duration of this trip was 2.5 seconds and the acceleration happened to be 2.5 as well. So take your time to record those properly, either by drawing on the file in the graphs that are provided or taking screenshots. After you've done that, you'll move on to writing a story problem. And in that story problem, you're only including the initial velocity, which was 1, and the distance that he traveled, which we know here was 10, 10.013 to be exact. What you'll find is oh, and actually one more thing. And of course we have to include the acceleration due to the fact that he is accelerating. So 2.5 would be the other given. So you're writing a story problem with only those 3 givens. Then you'll move on to 3A, B, C, and D, where you will be finding the final velocity, which technically we know from the graph here, but we're going to pretend we don't. And we're going to see if that matches up. And then we'll also be solving for time, which we do know as well, but we're going to pretend we don't, and we're going to see if it agrees with the simulation. Hopefully that helps, and if you do run into any questions, please reach out to your teacher.